All right, we're at show it here. We're at gotomath.com and we are working some calculus problems. We're in the section here of related rates, and if you click on this button here, you'll get a problem that looks kind of like this that'll pop up. However, these numbers are going to be different. All right. So here we are. Um, it says find the rate of change of the distance between the origin and a moving point on the graph of, and this is the actual equation to this graph, when x is equal to 2 centimeters dx over dt. We're just going to go ahead and round our answer to 2 decimal places. So let me actually bring up the whiteboard and let's get some pictures drawn here of what's actually going on, because this should help you out. So we're just going to kind of sketch over here the XY axis, and let's see, we'll make our, how about we make the line green. It was y is equal to 4x plus 3 if I remember right, so something with a slope of 4. Alright, so we got something like that, and we have a point actually, so there's like a car or something, whatever. This is actually moving along this line right here, and we're going to say that this is 2. How's that? We'll say this is 2. I know this is not going to be to scale, and of course we got the y-intercept here of, I guess we'll go ahead and write the information they gave us. So the equation to this line, right, is going to be y is equal to 4x plus 3. All right, and what are some other things that they gave us? X was equal to 2 centimeters, I believe. 2 centimeters, and there's our 2, so this, we know our x value is 2 here. And they also said that this point is moving in the x direction 4 centimeters per second. So it's moving in the x direction, okay? The x direction. And we're going to know what it's moving in a y direction. We'll need to know that here in a minute. So this is the information that they give us right here. And we're asked to find the rate of change between the origin and the actual point on the graph right here. So this rate of change, all right, this distance right here is changing, and we got to find that rate of change given when x is 2 and dx over dt is 4 centimeters per second. So we're going to need to know the, I'm just kind of doing a dotted line here, but anyway, should be, but what we need to know is we're going to need to know the distance formula, because it's asking for the rate of change of the distance with respect to time. So we're going to need to know the distance formula, and let's just do that in a different color here. What color do we want to do that in? Dark blue? I don't know. So the distance, remember, and we're going to do it like this instead of square rooting the right hand side. So the distance is equal to x of 2 minus x of 1, and we'll get to that here in just a second, squared, plus y2 minus y1, and that's squared also. So there's the distance formula right there. And what we're going to do now is we're just going to go ahead and take the derivative of this thing. Okay, so bring the 2 out front, and then we're going to write d with a capital D dt is equal to 2 times x of 2 minus x of 1, and then this is going to be dx over dt plus 2 times y2 minus y1, and then this is dy over dt. Okay, so we have a 2 in each one of these, and we can multiply through by half all the way across to get rid of these 2's and kind of get them out of the way. All right. I'm not going to write this again, but what we want to do is solve for this dd over dt, which means we're just going to take this d right here and move it diagonally down. Move it diagonally down. And then we will have solved for that. But there's some things that we need to, some numbers we're going to need to plug into this thing. And, well, we're going to need to know what x of 1 and x of 1 and y of 1 are. Well, we're going to go ahead and say that's going to be the origin. Right, so this is going to be our x of 1 and our y of 1, and then of course this point right here we're going to need to know what that is, and this is going to be our x of 2, y of 2, this point here. Well, that's pretty easy because we've already got x of 2, and that's going to be 2, but we need to know what y of 2 is here, and that'll come from our equation over here by just plugging x of 2 in, and we'll figure out what our y is. So that's pretty simple. Let's go ahead and just do that and get that out of the way. So we got 4 times 2 plus 3, right? So that's 8, 9, 10, and that's going to be 11. We'll write that right there. All right, so we have 0, 0. That's 1 point, and then we have another point, 2 comma 11. Right, that's just what we got right here. So there's our 2 points, so we can plug those guys in. And our dx over dt, they already gave us that. You know what? We'll just write it again right here. Dx over dt is equal to 4. But now we want to know what is dy over dt. We're going to need to know that and plug that in right there. Well, that's pretty simple. It's going to come from this, and what we're going to do here is, and I guess, where can I write this? I'm running out of room here. We'll just do that. We're going to take the derivative of this right down over here. Okay, I hate to have to do that to you, but the derivative of y is 1, but then we're going to write dy over dt, and then rewrite the derivative for x is just 4, and then we'll write dx over dt, and so therefore dy over dt, now we can plug in our numbers, 4 times, and our dx over dt is 4. So as you can see here, dy over dt is 16. Now remember, this is centimeters per second, so we don't want to leave that off. Right, centimeters per second, and remember this is centimeters per second, and of course, you know, these numbers are in centimeters here. All right, well, we've got everything we need now that we can plug into this right here. And I'm going to go ahead and write dd over dt. All right. And one other thing we're going to need to do is find the d here, the distance. Okay. We're going to need to find that distance. So what I'm going to do here is just go ahead and plug our numbers in. We have x of 2 minus x of 1. So here's x of 2 minus x of 1. Well, that's just that is going to be, where am I at? I am lost. That is not x of 2. Okay, 2 minus 0. So 2 minus 0, right? Let me just go ahead and write that in here. 2 minus 0. Oh my God. dx over dt is 4. Wow, I got confused there for a second. And then y2 minus y1, so 2, this would be y2, or sorry, y2 minus y1, so this would be 11 minus 0, and then dy over dt, which was 16. All right, so that takes care of the top part. And then we have the distance, and so this is the square root of, okay, the square root of this guy squared, and that's just going to be 2 squared plus, and then this guy right here squared, and that ends up becoming 11 squared right there. So now what we can do is just simplify this thing down. All right, And so this becomes 8, and 11 times 16. Um, I'll just write it here. And then 11 times 16 over, and then this is 4, and this is going to be 11 squared, and so that's going to be 11 squared plus 4 is, well, anyway, it should become square root of 125. All right, and of course we're going to go ahead and just approximate this, and so when you plug this in, this should approximate to 16.46. And of course, remember, this is centimeters per second, so we want to make sure we don't leave off. We used units up here, so we got to use units definitely in our final answer. And since it's a distance, right, it's going to be in centimeters, since that's what we're using here. Okay, we're not. This is not chemistry class, and they don't want it to convert to feet per mile or kilometers or whatever. All right, so there it is. Um, it was pretty simple. Well, maybe not too simple if you've never seen this, but it's a typical homework problem, test problem, whatever. You just do the distance formula and take the derivative of it with respect to t. This is implicit differentiation essentially, and then just plug in everything that you needed to derive up over here, and there you go. Okay, so let's actually go back. I kind of cheated on this, I will tell you. I brought the answer up just to make sure that my answer agreed with this answer, because I'd hate to have to work that thing out. It's a little mistake and be a mess. Okay, so anyway, we're at gotomath.com. Make sure you come up here and work some of these problems out, because what good is watching math videos unless you actually work some stuff out. So we're in this section. There's quite a few different problems for this section that's just like this one here. All right, so good luck and see you there. Bye.